All right. Well, I'm making a short video for you guys so that you can recognize how to do what's called properties of logarithms. Okay. This worksheet after your test is up on Canvas as well as this video. So watch this video, of course, first, and then do the problems. I'm going to do a few of them so you can see. Now, properties of logarithms. There's really only three we need to worry about for today. One is this. If you have a log, by the way, this is base 10. Remember that? If there's no number there, that's automatic base 10. So all of these problems are base 10. But if you have a logarithm that has multiplication, so this is all in one logarithm, not log base 10 of 6 times log base 10 of 11, but log base 10 of 6 times 11. That can be written as log base 10 of 6 plus log base 10 of 11. Now, if you're one of those people, you're like, Mr. Duncan, why is that? Here is a proof, a super quick proof for this. Let's suppose that I had log base 2 of 8. What that's actually saying, remember, is 2 to what power gives me 8? Well, the answer would be 3. 2 to the third power gives me 8. Okay? Well, you could write this as log base 2 of 4 times 2, correct? 4 times 2 is 8. Hopefully you're comfortable with that. So if I use my log rules that I just said, log base 2 of 4 plus log base 2 of 2. Okay? I'm going to slide this over just a bit. Well, what is log base 2 of 4? Log base 2 of 4, 2 to what power gives me 4? The answer is 2. 2 to what power gives me 2? The answer is 1. 2 plus 1 is 3. 3, 3. Okay? So I'm not saying you should do all that work. It's way easier in this specific problem to just do this. But you need to understand that this is called expanding logarithms. And so you can expand them, and sometimes it is useful. Okay? So that's the first rule, multiplication. The second rule has to do with powers. So let's look at number 3 together. Okay? This power, if you have a power, can be brought to the front of the logarithm. So I could write this 5. Actually, this covers both rules, both of the last two. Log of 6 divided by 11. And I'll prove both over to the side in a minute. So I can bring this 5. If it's a power of the entire thing, I can bring it out to the front. Well, then I can write this as 5. Now, I'm going to put this in parentheses because of all of this being inside. This would be 5 of log base 6, not log base 6, log of 6. Remember, these are all base 10 on this page, minus log 11. So let me go through the two rules. The first is if you have a logarithm, this thing that's here raised to a power, you can bring that out to the front. The second is if you have two things divided within the same log, you can make them minus. Okay? So my answer would just be this. Okay. Now I'm going to go over to the side and I'm going to prove why that's the case. So first, let's do division. Let's say I had log base 2 of 4. We should know that that's 2. Okay? You can hear in the background that I'm at the building. Okay? Okay, now take a second to process, but 4 could be written as 8 divided by 2. So we already know, the only reason I'm doing this is to prove it. If you're like, why is he doing 8 over 2? It's purely to prove this is true. So if I had log base 2 of 4, I'm saying 2 to what power gives me 4, and the answer is 2. I can also write 4, if I really want to, is 8 over 2. I would only do it to prove this. Well, that's not actually true. There can be times where this is helpful to solve something. Well, now if I use the new rule I just taught you of division, log base 2 of 8 minus log base 2 of 2. Well, we know that 2 we need to raise to the third power to get 8. So log base 2 of 8 is 3. This is 3 minus log base 2 of 2. 2 to what power gives me 2? The answer is 1. 3 minus 1 is 2, which is what we had before. So subtracting exponents, okay, or if you have division all inside of one log, you can split it into two different logs and subtract, okay? All right, the final rule is what about the power? So I'm going to write this. Follow me on this. It actually connects to the addition rule. So let's say I had log base 2 of 2 to the third, okay? I'm telling you, you can bring the 3 out front, right? Well, I'm going to write it this way. See if you agree with this. Log base 2, 2 to the third is 2 times 2 times 2. Well, according to the rule we just learned, we can then write this as log base 2 of 2 plus log base 2 of 2 plus log base 2, I'm going to write a room, of 2. We just proved that just a moment ago. Well, log base 2 of 2, by the way, is 1. Log base 2 of 2 is 1. Log base 2 of 2 is 1. The answer is 3. Okay? If we come back up here and put this 3 out front, so it's gone. We just said log base 2 of 2 is 1. So 3 times 1, there's your 3. Okay? If you want to ask me more about why this happens, I'm completely fine. But these are the 3 rules. If you multiply and it's all inside the same logarithm, you can divide. I'm sorry. Sorry. You can break it into 2 separate logs and add. If you divide, you can break it into 2 separate logs and subtract. If you have it raised to a power, you can bring it out to the front and work from there. Now I'm going to show you 4 and then a couple on the other sheet and we're done. Number 4 I want to show you because there's a little bit of a difference with number 4 and number 3. You see, because now notice only 2 is raised to a third power. So this would be log base 10 of 3 plus log base 10 of 2 to the third. You see that third isn't for both of those numbers. Then you'd bring the 3 out front. So log base 10 of 3 plus 3 log base 10 of 2. That would be my expanded logarithm. Okay? Now, part of what you're going to be doing is completing these. So you need to be able to do 2 and then 5 through the rest on this page. Okay? All right? I kind of want to see what you do with number 11. Now, I will give you this one thing. With number 11, look up. How can you write? If you type this into Google, you'll find it. The cube root. What is the cube root as a power? I want you to do a little bit of research there. What's the cube root as a power? So cube root is what power? Or what exponent? Okay? So you look that up. You're honor students. You can chase that down, okay? All right. On the next page, this is just condensing. So we're just reversing the process. So we have log base 10 of 3 minus log base 10 of 8. So we're just going to write it because it's minus. We're going to do log base 10, one single log of 3/8. That's it. Okay? Now 14 is a little tricky, but here's the logic on 14. I'm going to do that one just because of, actually, I'm going to see if y'all figure it out. All right? I know, I'm kind of a jerk sometimes. Number 16, I'm going to do 15 and 16. So 15, this 4 can come up as a power in both cases. So you have log base 3 up to the fourth, y'all, log base 10 of 3 to the fourth minus log base 10 of 8 to the fourth. So, because this is minus, I can do log base 10 of 3 to the fourth over 8 to the fourth. Now, some of you, and I'd love for you to ask me why I did it, I can write this as log base 10 of 3/8 to the fourth. So if you want to ask me that, I'll be glad to talk through that. On number 16, because it's addition, I'm going to do log base 10 of 2 times 11 times 7. And yes, you can go ahead and multiply those together. So 22 times 7, 14, and 14, 154. I'm going to check on my calculator. I believe I'm good on my math, but let me double check. Yep, okay. So this would be my condensed answer. So I need you to do any problem that I didn't do. So 14, 17, 18, 19, 20, 21, 22, 23, 24. Okay, and 25 and 26. So you need to finish this worksheet after you've watched this video. Okay, we can answer questions on the next day. Thanks a lot. Talk to you soon.